So today we're going to talk about some operations with polynomials. So a polynomial just means, let me get you set up here. What we mean by operations, polynomials, is we're going to talk today about addition, subtraction, and multiplication. We will move on to division, but just not quite yet. So what's a polynomial? Well, a polynomial, poly means many, so it has multiple terms, okay? So maybe something like 2x to the third plus 4x squared minus 5x plus 2. This will be a polynomial. Now, you're used to seeing something like just this part, and that would be a quadratic, and this is what we spent dealing with in chapter 1, but now we're going to kind of build on that, and so we'll have polynomials, which is more terms than a quadratic. Okay, so the first thing we're going to look at is we're going to do some addition of polynomials. Now, a couple of things we need to talk about. Before I show you how to add polynomials, I need to kind of refresh you on like terms, because we're going to talk a lot about like terms and how to combine them, so you need to know. So what like terms are they are terms that have the same variable and the same exponent. So maybe 3x squared and 5x squared, okay? So notice that that variable is the same. As well as the exponent. Another example of like terms may be negative 4x to the 7th power and 6x to the 7th power. Okay, as long as that variable and the exponent are the same, then they're like terms. The other kind of definition that you need to be aware of before we really get into adding polynomials is what this number is called right here in front. So that's called the coefficient. Okay, so the coefficient is the number that sits in front of the variable. Remember, if there's not one there, I hope you can remember what's supposed to be there. For example, if I just had x to the third, that coefficient would be an imaginary 1 there, okay? So we're going to talk about adding polynomials, and when we add polynomials, we combine these like terms. So let's talk for just a minute, and again, this is all should be review stuff for you. Well, but we defined like terms, but now I want you to think about how we combine those like terms. So if I had 5x to the third plus 6x to the third, well, how would I combine those? So what we do, once we identify the like terms, all we have to do is combine their coefficients, okay? Very important, they have to only be like terms when we combine them. So in other words here, 5 and 6 would give me 11. When we combine the coefficients, we leave the variable and the exponent alone. We're going to leave the exponent. Okay, so this is going to become 11x to the third. That portion is what we leave alone. Okay, we leave the variable alone and the exponent alone, and we only combine the coefficients. All right, so 5 and 6 is 11, and then we have the x cubes here. So let's look at a polynomial. In fact, let's look at two polynomials to add. So we're going to get back to here, adding polynomials. And I know I titled this adding polynomials to start with, but we had to do a little background. So now we're ready. So I'm going to give you two polynomials here, and I'm putting them in parentheses just so you can recognize the two different polynomials. Let's say x to the third minus 2x plus 8. And I want to add to that 7x squared plus 2x minus 5. So what I want to do is I want to look for the like terms, and all I have to do is combine them. And remember, when we combine like terms, we add the coefficients, we leave the variable and the exponent alone. So I'm going to start with the biggest exponent that I see. I see an exponent of 3. Okay, I don't see any others either in this one or this one. So I'm just going to go ahead. I've got x to the third here. And I'm done with the powers of 3. So now let's count down from there. Do you see any powers of 2? This first one, no. But I do see a power of 2 in the second one. So I'm going to go ahead and add that one in. So now I'm looking just for x's. So I have a negative 2x in the first, and I have a positive 2x in the second. So I need to stop and think, well, what is negative 2 plus 2? And I hope you answered that is 0. So these actually cancel out. So now I'm on to my constants, which are the ones without the variable. And I have an 8 and I have a negative 5. So 8 plus negative 5 would leave me with 3. So there's my answer. Let me give you one to try here. Let's try 4x to the third minus 2x squared plus 5. And to that I want to add, be careful here, I'm going to throw you off a little bit, negative x cubed minus x squared plus 4x minus 2. And just a hint as you get started, remember when there's no coefficient, there's an imaginary 1. I hope you've had a chance to work this out, so let's do it together. Start with the biggest exponent. I've got a power of 3 in this one and a power of 3 in this one. So together, remember I'm just combining the coefficients. This is a 1 here, so I've got 4 and negative 1, which gives me 3. And I leave the variable and the exponent alone. And I'm done with those. I'm going to keep going. I've got now an exponent of 2. So I've got a negative 2 and a negative 1, which would give me negative 3. Leave the variable and the exponent alone. If you're not good with the negatives, use your calculator. Negative 2 plus negative 1. Be very careful here. This one jumps straight to the constant, but if you look at the second one, there is an x term there, so I want to include that one since there's not one in the first. And then I have 5 and negative 2, which would give me 3. Okay, so let's talk about subtraction a minute. Now, when we think about subtraction, students always have trouble because of you've probably been taught same change before. So maybe you have 5 minus 3, and maybe your teacher, when you learned to subtract this, told you to same, change. Okay? So we're going to kind of build on that just a little bit. This time, remember, I'm talking about polynomials here. So it's a little more involved than this, so I'm going to put them in parentheses here, okay? I'm going to start with 2y squared plus 6y minus 2, and from that I'm going to subtract 2y squared plus 5y minus 8. All right, so what I want to do whenever I go to adjust this, I'm going to do same. I'm going to look at the parentheses as their own piece. Okay, so I'm going to say same. I'm going to change this sign. But what that means is I have to change everything in this parentheses. Okay, so I'm going to change everything that follows that subtraction sign. So when I do this, it's going to be, this one's going to change, this one, and this one. Okay, so I'm going to say same, change everything, because I'm looking at that second set of parentheses. And then if you look, really what I have here is an addition problem. And whenever I'm adding polynomials, I just want to combine like terms. Okay, so let's look at this one and let's combine the like terms. Let's do the squareds first. I've got 2y squared and negative 2y squared. So together, remember, I'm combining just the coefficients and leaving the variable and the exponent alone. So 2 and negative 2 actually give me 0, and those cancel. So I'm going to move on to the y's here. I've got a 6y and I've got a negative 5y. Again, watch those signs. So 6 and negative 5 would give me 1y. If you want to put the 1 in front, you can. It's not wrong. Those are canceled, and now I'm left with the constants, which is negative 2 and 8. So together, that would give me 6. And I have just subtracted those two polynomials. So let me give you one to practice on. Let's try 9x squared minus 8x plus 3. And from that, let's subtract 2x squared plus x minus 4. So I hope you've had a chance to try this one. I'm going to do my same change, and I'm going to change everything in the parentheses. And now I'm going to get my like terms together. I have 9x squared and negative 2x squared together will give me 7x squared, because I'm just combining the numbers in front. So now I'm going to look at my x's here. I guess I should cross these out. Negative 8x and negative x. So remember, there's that imaginary 1 in front. So negative 8 and negative 1 make negative 9. Those are gone now, and so now I have 3 and 4, which together would give me 7. So I hope you got that one right. If not, I hope you see where you messed up. Let's move on to multiplication. Now, before we multiply big polynomials together, let's take a minute, just like we did before addition, and let's take just a minute to talk about how we multiply things together. Now, if I asked you to multiply 3x squared times 5x to the 4, okay? When you multiply terms, what we have to do is we multiply those coefficients. And now if you think back to those exponent properties we talked about, not only do you multiply the coefficients, but you have to add the exponents, okay? So this is different. Remember, when we added, we left the exponents alone, but when we're multiplying, we've got to add those exponents because that base is the same, okay? So this would become 15x to the 6th, okay? Now, let's do a simple form of multiplication first because I think you'll remember how to do this. If I have a term that sits outside of a polynomial, let's say I have 2x to the 3rd, and I want to multiply that to 5x squared plus 3x minus 4. So if you recall, remember when we have something like this, we do what we call distributing. Okay, so we take this first term and we distribute it through to everything in the second set of parentheses. So here we multiply the numbers in front, so 2 times 5 is 10. And then we add those exponents together, so 3 plus 2 is 5. Again here, 2 times 3 is 6, and 3 plus 1 is 4. Then to the very last term, 2 times negative 4 is negative 8, and we just have the x to the 3rd. Okay, so that is simple distributing. Now, then after you learn to distribute, maybe you didn't distribute something with quite the exponents there, but what you did do was you did some problems like, and we've talked about this in class multiple times, something maybe like this, okay? Where maybe you learned it by FOIL. I know we've talked about distributing in our class, okay? So when you get something that looks like this, here's what you have to do. Every term in this parentheses has to distribute to everything in this parentheses, okay? So what I'm going to do is I'm going to start the first term, and I'm going to multiply it through. So x times 2x is 2x squared. Remember these imaginary ones right here. And then x times negative 5 would be negative 5x, okay? Now, this one has distributed to everything here, so I'm done with it. And I will move on to the second term, okay? So now I distribute this through to this parentheses. 3 times 2x would be 6x. And then 3 times negative 5 would be negative 15. So after we FOILed or we distributed, then we have to remember to simplify by combining like terms. Okay, and of course the like terms here are negative 5x and 6x. Negative 5 plus 6 is 1. So I end up with 2x squared plus x. And again, if you put the 1, it's not wrong. Minus 15. Okay? So this is the same concept. These are actually polynomials. So it's the same concept regardless of the polynomials that I multiplied together, okay? Every term in one parenthesis has to distribute to every term in the other parentheses. Okay, so for example, let's do negative x squared minus 2x plus 7 times x minus 1. Okay, so what we want to do is we want to take the very first term, because everything in this has to distribute to this, okay? So negative x squared times x, and I'm going to put a little 1 here as a reminder to you that there is an exponent of 1. All right, so that would give me negative x to the third. And then on to the next term. So negative x squared times negative 1. Remember, a negative times a negative is a positive x squared. I'm done with that term. Now I can move on to the negative 2x. So negative 2x times x would be negative 2x squared. Again, don't forget that little 1. And a negative times a negative is a positive, so negative 2x times negative 1 would be positive 2x. Okay, now I'm done with that term. Last one is 7, so it distributes. 7 times x is 7x, and 7 times negative 1 is negative 7. Okay, so after we've distributed all these terms, remember we then need to combine our like terms. So looking at this, I have negative x to the third. I have an x squared and a negative 2x squared, which would leave me with negative 1x squared. I have 2x and 7x, which would leave me with 9x. And then the minus 7 on the end. So let me give you one to try. Let's try this one. So take a minute to try this one and then we'll come back together and work it. I hope you've worked this one out now. So let's just do it together. X squared times x would give you x to the third. Again, there's a 1 here and a 1 here. X squared times negative 1 is negative x squared. Done with that, let's move on to negative 5x times x would be negative 5x squared. Negative 5x times negative 1 would be positive 5x. Done with that one. And we've got this 3. So 3 times x is 3x. And 3 times negative 1 is negative 3. So we'll gather our like terms together. We have the x cubed, negative x squared, and negative 5x squared would give me negative 6x squared. 5x and 3x would give me 8x. And then the minus 3 on the end. Okay, I hope you got that one right. And if you didn't, I hope you see where you messed up and can fix it for next time. Let me show you a special case quickly and then I will be done. Sometimes we have things, and we have also talked about this multiple times. If I have an exponent on the outside of a parentheses, what that means is this tells me how many times to multiply that parentheses. So how many times to multiply? Okay, so never, ever, ever, when there's a plus or a minus in the middle here, don't distribute that exponent because that's not the same. So what this tells me is I have 7x minus 2 times 7x minus 2 times 7x minus 2. Now, when you have more than two polynomials being multiplied together, you never, ever, ever multiply more than 2 at a time, okay? So what you want to do is multiply 2 first, and then multiply to the third. So let me show you what I mean. I'm going to look at just these two first, okay? I'm going to take the 7x, and I'm going to distribute. 7x times 7x would be 49x squared. 7x times negative 2 would be negative 14x. I'm done with this term. Take the negative 2 times 7x, negative 14x. Negative 2 times negative 2 is positive 4. Go ahead and combine your like terms. So I get 49x squared. Now I've got negative 14x and negative 14x, so that would be negative 28x plus 4. But I'm not done because remember I left that third piece up top. So what I need to do is go and bring that down and multiply it to that as well. Okay, so now I get 49x squared times 7x. So I get 343x to the third. Now 49 times negative 2. 49x squared times negative 2 would give me negative 98x squared. And I'm done with this one. Same thing with negative 28. So negative 28 times, or negative 28x times 7 would be negative 196x squared. And negative 28 times negative 2, again, two negatives would give you a positive 56x. I'm done with that term, and now the 4 will distribute through to give me 28x minus 8. Now I'm ready to gather my like terms. I have 343x to the third, negative 98 and negative 196 would give me negative 294. And then 56 and 28x would give me 84x minus 8. And I'm done. One more for you to try and we will wrap up. Let's have you try 2a plus 5 to the third power. And simplify your answer. Let's see what you get. I hope you've had time to work this now. So I'm just going to write it out 3 times. And again, 2 at a time. So let's do these two first. 2a times 2a would give me 4a squared. 2a times 5 would give me 10a. 5 times 2a is 10a, and 5 times 5, is 25. Again, get those like terms together. 10a and 10a is 20a. And to that, I'm going to multiply 2a plus 5. And I'm ready to distribute yet again. So I have 4a squared. If my pen will write. Times 2a, which would give me 8a to the third. 4a squared times 5 is 20a squared. 20a times 2a would give me 40a. And 20a times 5 would give me 100a. And then 25a plus 2a would be 50a. And 25 times 5 is 125. Like terms again, a to the third. 20, and I'm sorry y'all, this 40a should have an a squared on it right here. Well, there we go. 20a squared and 40a squared would give me 60a squared. 100A and 50A would be 150A, and then I have the 125 on the end. And that's it.